So if there's only one charge in this source region, then the potential energy, we know how to calculate it, and therefore the electric potential will be also easy to calculate if you only have one. That means in the summation that I just showed you before, you only have one term, right? So if you have a charge Q somewhere in space here, and you bring another charge Q test from infinity all the way to a distance r from Q, then we know that the potential energy of that interaction is given by K, Q, Q test divided by R, right? And therefore the electric potential, which is defined as the interaction between the two charges divided by the charge of the test one, will be equal to K, Q divided by R. Okay? So the electric potential at any point surrounding the charge Q, so charge Q in this setup is going to be my source. Right? So at every point in space, there's going to be a value of the potential. Say potential equals, we measure that in volts. Say potential equals 10 volts over here. Maybe over here the potential is 9 volts. Maybe over here the potential is 50 volts. Every point in space has a tag that tells you how much is the electric potential at that point. Okay? And for a point particle, the electric potential, we just wrote it, is K, Q divided by R. If Q is positive, then that electric potential will be positive. If the charge Q is negative, then the electric potential due to that point charge is going to be a negative number. Right? Now what does it look like, this electric potential? If I were to plot, say, in the z-axis, the potential, and this is the x and the y, right? And I'm going to put the source charge here. That's where my Q goes, right? If I were to do that plot, then what it would look like. The function, that function of 1 over r goes to infinity when the distance goes to 0, right? So for the points in the xy plane that are close to the charge Q, the potential, the electric potential, if let's say that Q is positive, say that is positive, then that electric potential shoots to infinity, right? So the plot that you would have would look like a hill, a mountain that goes to infinity near the origin, right? And I don't know if I'm going to be able to draw this very well, but that's what it will look like. It's a surface, right, that it has a large peak at the origin of the x and y axis. And it is, if the charge is positive, then that surface is above the xy plane, right? So it's sort of like a steep hill. And what would it look like if the charge is negative? So this is again the x and the y. That's the axis that has the electric potential. I'm going to plot it again in the z-axis, right? And if the charge is negative, so that you have a minus q charge here, then what you're looking at is a surface that goes down in negative value, and when you're at the origin, the value of the electric potential will be minus infinity. So this thing goes down very steeply. It's like a sinkhole. So that's the basic picture that we have for the electric potential of one charge. So we said that we have described the space surrounding a group of charges with the electric field, which is a vector. Now I'm telling you, let's describe the space surrounding the charges, a group of charges. Let's describe it with a new quantity, which is the electric potential, which is just a number. You might wonder, why two different things? Why are we using this idea that the charges modify the space surrounding them? Well, we're describing that that modification of the properties of space in two different ways, with a vector field, the electric field, and with in scalar, which is the electric potential. Why are we doing that? How are they different? Or which one is better than the other? Which one's more correct than the other? The answer to that question is that both descriptions are equivalent. Right? You can describe this fact that the space gets modified somehow. You can describe it by talking about the electric field, or you can describe it by talking about the electric potential. Both descriptions are equivalent. It's not like one is more correct than the other one, right? But again, if they're both correct, why bother having two? It's the same situation that you had with Newtonian mechanics. With Newtonian mechanics, you remember that when we started doing energy problems, we could still solve those problems using Newtonian mechanics, using Newton's second law, right? And we could solve them using energy. The only difference between them is that sometimes it's better to use energy, sometimes it's better to use Newton's equations. If the question is directly, what's the force on this block being pushed by this spring and so on? Clearly, you're talking about Newtonian mechanics. The answer requires a force, and Newtonian mechanics talks about forces. So that's the approach that you want to follow, right? But if the question had been, what's the velocity of the particle after they have collided with each other, what's the velocity and so on, velocity means that you probably could use energy, and it would save you some time just to calculate conservation of energy. Okay? So depending on what you're looking for and the situation, one approach might be better than the other. So the same thing is going to happen here with electric field and electric potential. Depending on the situation, depending on what you're looking for, electric field might be better for you to calculate than electric potential. If the question that you're being asked is, what's the force of the test charge when we bring it here? What's the force in this configuration of charges? What's the force on the charge on this corner? Then you probably want to use electric field, because they're asking you about force. An electric field is connected to the force through multiplication with the charge, right? But if the question had to do with energy somehow, what's the velocity of these charges after you let go of them and they're going to repel each other? What's the velocity at infinity, or questions of that sort? You probably want to talk about either electric potential energy or the electric potential of the system. It just depends on what you've been asked and what information you've been given.